Hello, welcome back to our learning channel MLSQR. And our topic for today is megaloblastic anemia for the clinical laboratory. And you wouldn't believe there were 10 related questions related to megaloblastic anemia in the ACP study guide. So stay tuned at the end for our Q&A. Every day, we often looked at vitamins B12 and folate as part of a healthy, balanced diet. And when we feel that we are deficient, we take vitamin supplements. But let's look at these two vitamins from a different view, in more detail from the clinical laboratory perspective. Vitamin B12, also known as cobalamin, is an essential vitamin with a cobalt ring structure linked to a ribonucleotide and acts as a critical coenzyme in succinyl CoA and methylation reactions necessary for DNA synthesis in the bone marrow for normal erythropoiesis and hematopoiesis. Folic acid, or B9, also functions in the transfer of methyl groups of nucleotides and amino acids. When there's a deficiency of B12, you can predict methyl malonyl CoA will increase. In the bone marrow, we see red blood cell megaloblasts in the erythroid precursors. And in the peripheral blood, we see hypersegmentation of neutrophils with 5 to 7 lobes in the nucleus. And interesting to note, chemotherapy takes advantage of this strategy with folate antagonists to inhibit DNA synthesis. In time, a macrocytic anemia develops. Another mechanism of megaloblastic anemia is B12 malabsorption due to intrinsic factor deficiency, which is caused by autoantibodies against the gastric mucosa, which secretes intrinsic factor necessary for B12 absorption in the ileum. B12 is very vulnerable to gastric juice, which is corrosive, so it needs protection with the protein coat. This protein coat is heptacorin, also known as transcobalamin 2, secreted by the salivary glands, and it protects the B12 as it goes through the gastric juices. Here we see intrinsic factor being secreted by parietal cells of the gastric mucosa. Did you observe that the protective protein coat was slowly dissolved by the corrosive gastric juice? Now we see intrinsic factor protecting and carrying the precious and vulnerable B12 molecule through the ileum for absorption. Also, note that any gastric or ileal resection or pathology may interfere with this process. B12 makes its long journey through the ileum with intrinsic factor, eventually making its way to the portal and peripheral blood circulation, and finally the bone marrow, where it serves its role as a key coenzyme in DNA synthesis. B12 and folate are intrinsically linked together for hematopoiesis in the formation of blood cellular components, all linked to the hematocytoblast or multipotential hematopoietic stem cell. As you can see, B12 and folate deficiency and malabsorption leads to failure of hematopoiesis, includes failure of erythropoiesis, myelopoiesis, which includes granulopoiesis and thrombopoiesis, resulting in pancytopenia, which was in our ASP study guide. Please see my other videos for more info. When you have anti-intrinsic factor autoantibodies, the gastric mucosa can no longer secrete intrinsic factor and we have pathology. Unfortunately, B12 cannot make its long journey to the bone marrow to serve its role as a key coenzyme in DNA synthesis. This bone marrow slide demonstrates erythroid megaloblasts. DNA synthesis is incomplete or halted nuclear maturation is delayed, resulting in nuclear cytoplasmic asynchrony. Few red blood cells are released into the peripheral circulation, and high apoptosis of defective cells aggravate the ineffective erythropoiesis. We can ask for a path review in the bone marrow. Note the large immature megaloblasts with a very fine chromatin pattern, high nuclear cytoplasmic ratio, and a thin rim of blue or xerophilic cytoplasm. Observe the nuclear cytoplasmic asynchrony demonstrated by immature blast-like nuclei, but with more mature appearing cytoplasm, as it is accumulating polychromatophilic hemoglobin, just like in a nucleated red blood cell. In any macrocytic anemia, keep a keen eye for hypersegmentation, defined as 5 to 8 lobes in the neutrophils. This illustration shows the hypersegmentation of the neutrophil along with macroavalocytes with targets and hypochromasia, which RBC histogram is consistent with megaloblastic anemia. So, based on the low H&H and MCV, we would classify this anemia based on MCV as one of the macrocytic anemia where the MCV is greater than 100 femtoliters. In megaloblastic anemia, what are your predictions of the CBC parameters? Our Q&A quiz is based on the ACP study guide, which is similar but not exact. Thank you for your time and attention and subscribing, and I hope to see you in the next video.